All right, so what do you guys think? All trapezoids are quadrilaterals, true or false? True. Quadrilateral means that it has 4 sides, and all quadrilaterals have to have 4 sides. What about all trapezoids are parallelograms? That is false. A parallelogram has 2 pairs of parallel sides. And a trapezoid only has 1 pair of parallel sides. All right. Go ahead and pull out your new notes packet. This is going to be kind of a short section before our next test. We're going to do 3 sections in Module 11, and then we're going to take a test over that. That test is going to be 2 weeks from today, so the 23rd. And then we will finish up Module 11, the rest of that module, right before we study for final exams. And we'll have our last test about a week before final exams. All right, we're going to be talking about area and perimeters. Today, our focus is the area of quadrilaterals, although we did stick in the area for triangles because that comes into play for a lot of our oddly shaped polygons. So the area of a triangle, does anybody happen to remember that formula? It is 1/2 base times height. And we are going to learn a second area formula for triangles in case we don't know the base and the height. We'll talk about that in just a moment. How about area of a rectangle? How would we find the area of a rectangle? Length times width. Length, we will often use a cursive L. And then for width, we often use a lowercase w. What about for a square? Tell me about the length and the width of a square. They're all going to be the same. So the length and the width are going to be the same. So instead of saying length times width, we normally will say length squared. Or sorry, not length squared, side squared, my bad. It's the same thing as length times width, but the length and the width are the same thing. So we take that distance, we call it S for the side of the square, and we multiply it by itself. All right. Area of a triangle, formula number 2. If we know 2 sides, we don't have the height. Height has to be perpendicular to the base. I just know 2 sides of the triangle, and I know the angle in between them. So say I know these 2 sides. This would be the angle in between them. This is my included angle. The area formula is 1/2 AB sine of angle C. This angle here, this is the included angle. So we're going to go ahead and write that down underneath our area of a triangle formula. Area of a triangle is equal to 1/2 AB times sine of C. A and B are side lengths. And again, C is the included angle, the angle in between them. Yes. Oh, thank you. Sorry, dear, I didn't hear the door. Thank you much. So I want to practice a little bit with this new area formula for a triangle. So let's look at example number 1. And again, we're using this area formula right here. So 1/2 the product of two adjacent sides, two touching sides, and the sine of the included angle. You are going to need a calculator for this. If you don't have a calculator handy, come up and grab one of my yellow calculators. All right, so on example number 1, part A, I know all 3 sides of this triangle. But to use my 1/2 AB sine C formula, I don't want all 3 sides. I want 2 of the sides, and we have to be really picky about which 2 sides. How many angles do I know in this triangle? Just 1. So this is my capital C. And then I need the 2 sides that are touching that angle. What are the 2 sides that are touching the 24-degree angle, angle P? Yep, PQ and PR. These are the 2 sides that we want to use. So we're going to call one of them A and one of them B. So now I'm going to substitute into my formula. So 1/2 times 5.5 times 3.6 times sine of 24 degrees. Once I get everything substituted into my formula, I'm now going to grab my calculator and I'm going to type it in just like I see it. You can put in the fraction 1/2, or you could use 0.5 for that first value. And then inside parentheses, you're going to put one side length, 5.5. Inside a second set of parentheses, you're going to put 3.6. Close that second set of parentheses, then hit the sine button. If you don't remember where that is, it's right here next to the pi button on your calculator. And then you're going to enter 24. Before you hit enter, double check that up here at the top, it says DEG, not RAD, or it's going to give you the wrong answer. DEG for degrees, because our angle has been given to us in degrees. And tell me what you get. .0266. So we're going to do 4.027 because we're going to round it. So the area of our triangle is 4.027. Do we need units with that? What kind of units? Super close. Not just centimeters though. The 5.5 was centimeters. The 3.6 was also centimeters, and I'm timesing them together. What do we call it when I take something and times it by itself? Squared. So this would be centimeters squared. Area will always have squared units with it. Let's look at part B. How many sides do I know on part B? 2. How many angles do I know? 2. We got to be really careful about which ones we're going to pick here. So area for a triangle is equal to 1/2 AB times the sine of C. I only have 2 sides, so this and this have to be my A and my B. So I'm going to label this one as A and this one as B. So which angle would have to be the one that I put in for C? Look at the other picture. Where was the angle located in relationship to the sides? In between them. So which angle do I need here? I need this guy right here. I don't know the size of that angle. Do I have the ability to find it though? Yes, by doing what? Yes, we're going to add 52 and 33 and angle C. And when I add all 3 of those together, it should add up to what? 180. 52 plus 33 is 85. And what is 180 minus 85? How much? 95, thank you. So 95 degrees is what we're going to put in for C. So I need sine of 95 degrees. So area of my triangle is 1/2 times 9 times 12 times the sine of 95 degrees. Kind of running out of room over there. What do you get when you put that into your calculator? 53.79. What are the next 2 numbers? 4, 5. This number right here, because it's a 5 or bigger, does what to the one right ahead of it? Rounds it up. So that's going to round up to a 5. And do I need units with this? What would those units be? Centimeters squared. Nice job. All right. Number 2. An isosceles triangle has legs of 12.25 yards long and a base angle of 55 degrees. What is the area of the triangle? Let's go ahead and sketch this triangle here. What do we know about an isosceles triangle? What makes an isosceles triangle different from a scalene triangle or different from an equilateral triangle? 2 sides are congruent. And it has 2 angles that are congruent. So on my drawing here, these would be my 2 congruent sides. So these would have to be my two congruent angles. And we call these two angles here the base angles. The two congruent angles are both referred to as base angles. The legs of this isosceles triangle are 12.25 yards. I knew it couldn't be the bottom of the way I drew this triangle because they didn't say that it was the base. Okay. And then we know that the base angle is 55 degrees. So this angle right here is 55 degrees. And this angle right here would also be 55 degrees because that is congruent to the other base angle. Can I use 1/2 base times height on this triangle problem? Or do I have to use the new one, 1/2 AB sine C? I have to use the new one. I don't know what the height of this triangle is. The height is never going to be a slanted piece. It has to be perpendicular to your base. So area for a triangle is equal to 1/2 AB times sine of angle C. How many sides do we know? We only know 2 sides, so we have to use those 2 sides for A and for B. And they are the exact same size. So one of them is A, the other one is B. So I'd have area for a triangle equals 1/2 times 12.25 times 12.25 times sine. Do I put 55 degrees in here? Why not? It's not between those 2 sides. This is the angle that we needed, or that we need. Here's my included angle. How can I find that included angle? There we go. Yes, 55 plus 55 plus the measure of angle C equals 180. What is 55 plus 55? 110. So 110 degrees plus the measure of angle C equals 180. And then I subtract 110 from both sides, and we get 70 degrees. So that's what we're going to put in here for angle C. Close my parentheses and type this into my calculator. And what do we get for the area of our triangle? .506, and then there's a 3 here. If this fourth number is smaller than 5, what does that do to the number right in front of it? Keeps it the same. So this is going to be 70.506. Do we have units with this? Yards squared. Circle up my answer here. Nice job. So that's a little bit of practice with our brand new triangle formula for area. we've talked about the area formulas for rectangles and squares. I want to talk about a couple different types of quadrilaterals now. Parallelograms. The area formula for a parallelogram is base times height. So on my picture here, we're looking at the bottom as one base, but then the top is also a base. And both the left and right sides are bases. So I decide which base I'm going to use in my formula based on where the information is about the height. The height of this particular parallelogram is making a right angle with the bottom. So I would have to use the bottom base because the height is touching that bottom base and it's forming a right angle with the bottom base there. Area of a trapezoid. This one kind of reminds me of the mid-segment formula for a trapezoid. We do 1/2 times the height times the sum of the two bases, base 1 and base 2. The bases will be the parallel sides. And the height is perpendicular to the bases. It'll be perpendicular to both of them. They only show one right angle right here, but it is perpendicular to both of those bases. And then the last one that we need to learn a formula for. This works for both a rhombus and a kite. For a rhombus and a kite, we need the diagonals. This is 1/2 diagonal 1 times diagonal 2. Yes. The height is always perpendicular or sometimes you'll see this symbol to the base. Perpendicular again means forms a right angle. All right. Let's try some practice problems. Some of them are going to be triangles. Some of them are going to be parallelograms. Some will be trapezoids. Some will be rhombuses, and some will be kites. If you go ahead and flip over to page 2, you'll see quite a few of these shapes pictured there. I think we've got 10 shapes drawn. So first shape we have is a triangle. I have two formulas for the area of a triangle. There's the new one that we just learned, 1/2 AB times the sine of angle C. What was the other formula, the first formula that we had that we wrote down at the top of the previous page? 1/2 times base times height. Do we have a base and a height that go together? Do we have a side that is perpendicular to another measurement that we have here? Yes, because this is what kind of triangle? It's a right triangle. So these two sides here, this 8 centimeter side, and then the side that is perpendicular to it, this 3.5 centimeter side. One of them is my base. Why don't we go ahead and call the bottom the base? And the other one is the height. I could have labeled that the other way around. The base does not mean it has to be at the bottom. The base will always be a side of my triangle, and the height will always be perpendicular to it, but it doesn't have to be on the bottom. All right, so we're not going to use this formula. Area is 1/2 times 8, my base, times the height, which is 3.5. What is 1/2 times 8 times 3.5? I think somebody said something, but I didn't hear. 14. Yes, ma'am. Yes, give me just one moment. Do we need units with that? Centimeters squared. Let's look at part B. Again, we have two formulas for the area of a triangle. 1/2 base times height, or 1/2 AB times the sine of angle C. Do we know any of the angles in the triangle here in part B? I don't know the size of any of those angles. So can I use the new area formula? Nope. Can't use this one because we don't know any angles. The base and the height have to be perpendicular to each other. Do we have that? Do I have a side and the length of something that is perpendicular to it? Which side do I have? Which side should I use? 7. What am I saying? You're welcome. All right, so we're going to use 7 as our base because that is a side of the triangle. And what do I have that is perpendicular to that? Forms a right angle. It does not have to be part of my triangle or even drawn in my triangle. 3 centimeters. This right here is showing me that it's perpendicular to my base, and it is perpendicular to this line here that extends out as far as the farthest tip of my triangle. So this right here is my height. So the area of the triangle is 1/2 times 7 times 3. Now I need you guys to multiply those pieces together for me. 1/2 times 7 times 3. 10.5. Do we need units with that? Centimeters squared. A lot of these examples are using centimeters. Be careful though. Look at the units that you've been given in the problem. It won't always be centimeters. I'm going to give you guys about 2 minutes to do part C on your own. Decide whether you're going to use the original area triangle formula or the new one that we just learned. Remember, to use the new one, you have to have an angle. If you use this one, the base and the height have to form a right angle with each other. Like I said, I'm going to give you about 2 minutes to do that one, and then we'll check back in. Which formula, old one or new one? Old one. Can't use 1/2 AB sine C because we don't know any of the angles. All right, so I know I have 1/2. And then I have to decide which of these sides is my base. What side did you use as a base? There's more than one right answer here. You used 5 right here, so we could use 5 as our base. That is a side of this triangle. What is perpendicular to the side that is 5? Because that has to be my height. 4.8 is the one that's forming a right angle with that side. So this would have to be your height. What other side could you have chosen as your base? You could have chosen 6 right here. If you chose 6 as the base, what is perpendicular to that side? Which one? 4, yes. It is forming a right angle with this base right here. So this would be my height. We could do this one either way. You should get the same answer either way. What is the area of this triangle? 12. Do we need units? Centimeters squared. Nicely done. I want to look at the next row down. That's probably where we're going to stop. So we're going to look at example D next. What kind of shapes do we have here? Still triangles? Trapezoids? Kites? Parallelograms. We have parallelograms. What is the area formula for a parallelogram? Base times height. Remember, the base and the height have to be perpendicular to each other. And I see right here, this side is making a right angle with the bottom. So this would be my height, but I don't know how big it is. Do I know how big the base is, the thing that is forming a right angle with that? Be careful before you answer. How big is my base? Remember, I want the side of the shape. We have to go from D over to C. How big is it from D to C? 23. That is my base. I don't add the 7 onto it because my shape does not go that extra 7 feet. My base, the bottom of the actual shape, is just that 23 feet. So I have area of my trapezoid is equal to 23. And now I need to find the height. I want you guys to look carefully at this shape right here. What kind of a shape is that I just highlighted? That is a right triangle. Do I have the ability to find that side that I have labeled as H, the height, using what I know about right triangles? How do I find a missing side on a right triangle? Pythagorean theorem. A squared plus b squared equals c squared. We always fill in c first because that's my hypotenuse. And how do I identify the hypotenuse on a right triangle? It's across from the right angle. Which side here is opposite my right angle? 25. So this is my hypotenuse. So I'm going to put that in for C. So I have 25 squared. So then for A or for B, I want to put my two sides. What are the two sides that I have here then? 7 and H. So I have 7 squared plus H squared. What is 7 squared? 49. So 49 plus H squared equals, what is 25 squared? 625. Then we're going to subtract 49 from both sides. Thank you, dear. What is 625 minus 49? 576. Then we do the square root of both sides. That'll make the squared cancel out on my H. What is the square root of 576? 24. If that had not come out to be a whole number, I would have used this number underneath the radical as my height. I'm not going to round that when I put it into the formula. So my height here is 24. So I have 23 times 24 to get the area of my parallelogram. How much? 552. Do we need units with that? Feet squared. Very nice job. That is where we are going to pause in the notes for today. We will pick up with example E tomorrow. The homework that you guys grabbed on your way in the door is going to be due on Thursday. Due Thursday this week. Of the problems on that homework, with what we've practiced so far, you guys can do the first two, numbers 1 and 2. You are welcome to try some of the other shapes, but we haven't done any examples with things except for triangles and parallelograms so far. So the rest of the shapes we'll do examples of tomorrow in class so that you can finish that homework up.